What's up, math fans? I know you mastered arithmetic sequences and arithmetic series, so now we're moving on to geometric series. So I'm already expecting that you know what a sequence is, what a series is, and how to find the recursive formula for arithmetic series, how to find a explicit formula for arithmetic sequence and series, how to find a recursive and explicit formula for geometric sequence and series. And now the last thing to do is just add them up, and that's the sum. So there's a formula for finding the sum of an arithmetic series, and now there's a formula for finding the sum of the first n terms in a geometric series. All right, and here's the formula. If you want to see the proof of the formula, because I did do the proof for arithmetic, if you want to see the proof for geometric, leave me enough comments and I'll do a separate proof on that. It's pretty simple. So even though it looks crazy, again, it actually makes sense. So just got to understand two things here. A1 is the first term, you knew that already, and R is the common ratio. Let me explain what I mean by common ratio, although you should already know. So let's say I'm trying to find the sum of this series here, and this is given as the explicit formula. So I want to understand what I'm looking at, so I'm just going to list the terms for now. So I'm going to find the sum from n equals 1, that means the first term, to the fifth term. So right away I know that n is going to equal 5, meaning I want the sum of the first 5 terms. Let's see. First term means I take n equals 1 and I plug it in for n, wherever I see n in my explicit formula. That's 1 goes here. 2 to the first power is 2. All right, I'm following PEMDAS, means I do exponents first. 2 to the first power is 2. 2 times 3 is 6. So my first term is 6. All right? My next term, I just did n equals 1. Now I'm ready for n equals 2. So I plug in 2 here. 2 squared is 4. 4 times 3 is 12. Then, after I do n equals 1 and 2, now I'm up to n equals 3. Take the 3, plug it in for n. 2 to the third is 8. 8 times 3 is 24. My third term is 24. Fourth term, n equals 4. Put the 4 here. 2 to the fourth is 16. 16 times 3 is 48. So my next term is 48. And finally, I'm up to the fifth term, and that's where I know to stop, wherever this number is up here. So I take 5, plug it in. 2 to the fifth is 32. 32 times 3 is 96. So my last or fifth term is 96. If it was a sequence, I'd put commas. It's a series, so excuse me, so I want to add them up. So I need the sum of the first 5 terms. 1, 2, 3, 4. Those are my first 5 terms. Notice, you know it's geometric because you can tell from 6 to 12, you multiply by 2. From 12 to 24, you multiply by 2. From 24 to 48, you multiply by 2. So you know that you have a rule. That rule is known as R, the common ratio. The common ratio is 2. You also knew that because the answer is right there. That's your R. How do I know? Because my explicit formula that I learned in my other video is this. A sub n is equal to a sub 1 times r to the n minus 1 power. So I know a clue is if I have a base, that's my r. All right? This was given as part of the question, so I know it doesn't match perfectly the exponent I'm used to, but because it's part of the question, I'm not going to tweak what's given to me. I'm just saying that I know my clue here is that the base, or the r, is 2. What does get tweaked is the a1. It's actually 6, not 3, and that only occurs because the exponent is n instead of n minus 1. All right? But the common ratio is the same, still 2. So that's helpful, so I'm going to write that. R equals 2. What else do I need to know? Well, I just need to add them up now. So I'll get a calculator and add them up, and you'll get an answer. And that works all the time, because sum means add. But just in case I need to use a formula, or if it's multiple choice and they say which formula is going to represent the sum, well, here's my formula. S sub n, which means the sum of this. Technically, I can replace the n with a 5, right? S sub 5, the first sum of the first 5 terms, is equal to the first term, right? A1, which is 6 times 1 minus, what's r? And this question is 2. 2 to the n power, and n is 5 terms. 2 to the 5th power, over 1 minus r, which is 1 minus 2. So we got lucky enough, we don't even need a calculator because you already know these numbers. 6 times 2 to the 5th we said earlier, but if you forgot, it's 2, 4, 8, 16, 32. 2 to the 5th is 32. So that's 1 minus 32 over 1 minus 2 is negative 1. I can divide by negative 1. I don't need a calculator. So that's 6 times negative 31 over negative 1, which I'm going in a weird circle here, is 6 times 31 is 618, right? 186. And then negative divided by negative is positive. So my sum is 186. You can check my math by actually just straight adding them up. But that is an application of the summation formula for a geometric series. That's really all you need to know. Sometimes, and I've seen multiple choice, where they don't do the math straight like this. They want to get fancy for some reason, and they will distribute the 6. Is it necessary? No, but they'll write it as 6 minus 6 times 2 to the 5th over 1 minus 2. It's the same thing. It leads to the same answer, 186. Let's move on. This was an old Regents question. Question said, you start with $33,000 and you get a 4% increase at your job every year. How much money will you have after the first 5 years? So you might want to break this down into how much will you earn in the 5th year alone, and then how much will you have in total, the sum of your first 5 years. So that might be the sum where n equals 1st year to the 5th year, okay, of, let's see how, this is interesting. So I know my A1, it's usually the given, is $33,000. And I know my rate is going to be 1.04. Now, do you know how I got that? Because if I'm getting an increase of 4%, that means I get 100% of what I already had plus another 4%. And 100% plus 4% is 104%. Now I got to figure out what exponent is going to go here. And that exponent will be what I said earlier, n minus 1. N minus 1. So this is in the form of a to the n equals a sub 1 times r to the n minus 1, where my r, my ratio is 1.04. Here's why it makes sense. The first year, n equals 1, right? I plug in 1 here, 1 minus 1 is 0. Anything to the 0 power is 1. Boom, this whole thing is 1. 33,000 times 1 is still 33,000. So it makes sense that my first term is 33,000. My next term, then I'll start to get my money increasing, and you'll see what the second and third and fourth term is. But I don't need to know all that. I don't need any of this. All I need is this formula, because the question is going to say, what's the sum? So I need my A1, that's this, and I need my R, and my R is 1.04. So let's go. S sub n is equal to 33,000 times 1 minus 1.04 to the, what's n? 5 years, right? I want to know from 1 to 5 years. So to the 5th power over 1 minus 1.04. So I'm going to get a negative on top and the bottom, which will give me, of course, a positive answer. You're expecting a positive answer. I don't have a calculator. Actually, you know what? We'll do this together. So we'll type this whole thing in and see what happens. So that's 33,000 times 1 minus 1.04 to the 5th power. That gives me negative 7149.54 divided by 1 minus this is just negative 0.04, and I get an answer that looks like this. So I'm going to ask you to check my work. And I'm going to ask you to finish that on your own if you're not sure. Let me know what your answer is. Thanks for watching. See ya.